an N weekly look at what's going on in the world of C++, chatting with guests from the community. And now, for your security, John has a disclaimer to read.
Thank you very much, Phil. We hope that our security systems provide some deterrence to crime. However, the association can never be crime-free. For example, it is possible for someone to enter the property under false pretenses to commit crimes, for residents to commit crimes against their own neighbors, for guests of residents to commit crimes, and for employees to commit crimes. Guarantee your safe security. You should not rely on the association to protect you from loss or harm. You should provide for your own security by keeping your doors locked, refusing to open doors to strangers, asking workmen for identification, installing a security system, carrying insurance, etc. All right. So this obviously was a tribute to our guest, Patricia, who has made a name for herself talking about security issues. How are you doing, Patricia?
I'm doing great. Thank you very much, John.
So you guys have something in common for the last week, right?
Yeah, we are both in Norway at the moment, just outside Oslo. Maybe, Patricia, you want to say a bit more?
Yeah, we're at NBC Tech Town in Kongsberg, so about an hour and a half outside of Oslo, and just wrapping up the conference just a few hours ago.
I don't know about you, Patricia, but I'm really tired after this week. I had a 2-day course, and then I had to do another talk as well. So I don't know what you've been up to.
Yeah, I'm pretty exhausted. I also taught a 2-day course, and then I did the keynote, and then I had a talk today as well. And so, but
and I think you missed something. You also hosted a meetup as well.
Oh yes, and I forgot the meetup. Yes, and I hosted a meetup
So,
with Jason. And it was awesome on a panel. Yes.
So the organizers are squeezing you for everything they can, and as a conference organizer, I applaud that.
I'm definitely working for my ticket here.
That's right. If your speakers don't go home exhausted, you haven't done your job as an organizer. I was actually in Oslo just a few weeks ago, but that was entirely unrelated to technology. My wife and I did a cruise up the Norwegian coast. Well, you know, we've always been told you should do that sometime if you can afford it. Hey, I gotta compete with Phil in the pun department. That's tough. That's asking.
No way.
Oh.
A slow beating. Oh man. All right. So yeah. So it's been a great conference. Is this your first time at Tech Town?
No. I've been here every year since they started. Well, every year. It's not that many years. It's only 3 years. So this is the 3rd year. But yeah, now Olve Maudal, who is the content director or whatever. I don't know if his title. He pulled me into the agenda committee on the first year. So it's very nice to have a C++ conference, which is in Norway, because we haven't really had that before.
Well, let me ask you a question. I have to ask this question. Is it a C++ conference or not? It doesn't say it's C++.
Yeah.
It says tech.
It's called Tech Town because the city, the Kongsberg, is called Teknologibyen. So that's in Norwegian. It basically means technology town. And so the name kind of comes from the place. But yes, it is definitely a C++ conference, and with some like added material for embedded and for and security. But the main content is definitely C++.
Well, that's the way it should be.
Yeah.
So 3 years.
Yeah.
Okay. Has it evolved in that time, or is it mainly just the same thing, more intense?
Well, it has evolved a little bit, but it's still quite small. Like, well, it depends on your scale. I don't know how many attendees does Cpp.con have.
Well,
probably
we're a little bit under our projection this year, so I don't think we'll make 1,500. We were on our way to it, and then in the last month, things. I think what's happened, with a little bit of surprise to me, is when the hotel filled, we stopped getting registrations, or at least I shouldn't say stopped, but it slowed down. That was kind of a surprise, because in Bellevue, when our hotel block's all full, we still got people coming. they couldn't stay in an official hotel, but there were other places they could stay, and that was good enough for them. But apparently this year, because we are in a particular hotel, if people can't get in that hotel, then they say, well, I guess I can't go, which is really weird to me. It's like, well, in Bellevue, you're willing to, you know, take a ride into the conference, but in Aspen, you're not willing, or I mean, in Aurora, you're not willing to do that. So it seems strange to me, but we'll just have to deal with it. Yeah.
No,
so,
no. So we're smaller. Like I would guess, I haven't checked, but I would say we're like maybe 300-400 attendees. But it's still like this year it was 5 tracks, so that's quite nice. You have a lot of options, and
that's a good size conference.
And so it's 2 days. Yeah.
What did you say?
So it's a 2-day conference and 2 days training. And then around I would say maybe 400 people, attendees.
Okay.
So it's quite, what I like,
So I came this year, and I came the first year. I didn't come last year. So I noticed a bigger delta, and it's definitely much bigger than it was the first year.
Yeah. I guess for me, it's like, it's grown like slowly, so I don't see it as much, but it's still very intimate conference, because you have a lot of speakers, and then you have not that many attendees, so it becomes all of the speakers are very accessible to talk to, and so like a little bit like on CPP on C as well, because it becomes a little bit intimate when it's smaller, so that's nice. I like it. But I also like that it's in Norway, so I don't have to travel so much.
Well, that's more of an advantage for some people than for others.
Yeah, no, I'm sure anyone who lives really close to CPPCon really likes the fact that CPPCon is close.
Right. So Phil, you did a class there. Is it the same course you're doing for CPPCon on test-driven development?
Yes. It is, yeah. So anyone that didn't make it to this one has another chance in Colorado in a couple of weeks, I suppose.
Yeah, very close. Get that registration in. There's still room for class. At the new venue, we've got a lot of space, so I don't think any of our classes are in danger of selling out. That's bad marketing. I should say get that registration in because we're going to sell out. But the truth is, we have the space, so we want to have people show up for the classes if at all possible.
I would say, prove John wrong, sell out.
There you go.
I've spoken to several attendees in Phil's class, and they said it was really excellent. So I'll pass that along.
That's money well spent paying them then. Yeah.
All right. So you did a keynote, you did a meetup, and you did a talk. So tell us a little bit about what you presented this week.
Oh, wow. Yeah, the 2-day training I did is a training I call Insecurity and C++. So it's basically scaring people for 2 days. No.
Excellent. Yeah. I think that's pretty low bar. You talk about C++, it's pretty easy to scare people.
Yes.
Okay, and we're going to go over the overloading rules. And it's only a 12-day course, so we can cover most of the overloading rules.
We spent like the whole first day was mostly talking about numbers and all the strange things you could do about numbers, and but the second day they wrote shell code, and they also tried to bypass checks in code, and so they've but I basically, one of the things I wanted to make sure is that everybody realizes how C++ is vulnerable in many situations, but also that a lot of the things that make C++ code safer are things that make C++ code better anyway. Things that you want to do to reduce bugs, because a lot of these things that are security issues are things that we normally think of as bugs.
Right.
And so a lot of the same techniques that you would use to increase the quality of your code, and also a lot of tooling that people should just use, like sanitizers and tests and warnings and all sorts of things, and so
a lot of security vulnerabilities are essentially attacking the corner cases.
Yeah.
Right.
And
so
we have
quality code.
corners.
Yeah, quality code. either has fewer corners by design, which you can often do. I think one of the cool things about, if you look at how algorithms are often developed, there aren't special cases for edge cases. It's just defined in such a way that the edge case handles itself. And I think that's beautiful, because when you try to put in special code for the edge case, then you have the edge case between the edge case and the normal case. So now you have another edge case. You have this infinite loop of adding in one little patch to cover this part, right? So, but yeah. So I think, I'm not an authority in security, but this does seem to be a theme overall, is that the security vulnerability is attached and is trying to attack a particular edge case.
Yeah, and very often what you see is that there's a higher density of vulnerabilities and code that doesn't run often. So often in error situations, things like that. And that's often code that we don't test very well, because we test all of the correct situations and all of the semi-correct situations. But then we have error code paths that we hardly ever exercise. And so often you will find, and this is true for bugs as well, you will find a higher density of bugs in code that hardly ever runs, because people are not exercising it as much.
And they may not have thought about it as much when they originally wrote it, because it's like, well, okay, we kind of have to deal with the error situation, but it won't happen often.
Exactly. And so you see that. So in error, so in code that only runs infrequently, you'll see more vulnerabilities, but also in complex code, like people will write really complex loops, especially using pointers, very high risk of vulnerabilities in this code. But we know already it's code that is really hard to reason about. And so basically, a lot of the training is motivating people to write cleaner code for security as well, not just for maintainability. But a lot of the things that give more maintainable and more understandable code is also going to make the code safer.
So if you want to upgrade the quality of your code, the way to pitch this to management is that it makes it more secure. Give us time to do a quality audit on our code, but we'll call it a security audit instead of a quality audit. And instead, we'll just try to upgrade the overall quality of our code, but we'll tell them that it's about security. Because really, it's both, right?
It is.
Higher quality code is more secure, and more secure code tends to be higher quality.
Yes.
Because the way you made it more secure was by getting the bugs out. Yes.
So instead of writing custom loops for things, use an algorithm if you can. Using modern C++, replacing explicit new and delete by using unique pointers, having explicit control of your lifetimes, so that you don't have use after freeze or double freeze. All of these things that we consider to just be exactly. But those are the same kinds of things that will fix vulnerabilities in your code.
And funnily enough, all of these were themes that came up in my TDD class as well.
It's all of a piece. It's just how you're looking at it, right? Yeah. You know, speaking of classes, I was going to say Matthew Butler is doing a security class at CPPCon, and I didn't think about it, but the name he picked for it was something like exploiting C++. And of course, he's not really teaching people how to exploit C++. He's teaching people how to write code that can't be exploited, right? Yeah. So I thought that was obvious. And yet one of the interesting things about it is that the class was really popular among our volunteers, because we allow volunteers to go to classes under a special discount. And it was a really popular class among young people. And it was like, they know you're not really teaching how to do exploits, right? You're not really teaching people how to. So I was teasing him about that. But that's one of the things he was saying as well. He was saying, no, we're really just teaching people how to write good code. There's no secret to security. The secret is write really good code, and
And the tooling as well. We've gotten so much good tools, especially with Clang, and then afterwards, like other compilers being inspired by that. So all of so one of the things that I'm seeing is that projects that already had really good code coverage now can use those tests and run them with sanitizers and find things. And that's what security researchers do as well. They'll take your project, if it's open source, and they will modify all of your builds to run all of your tests with sanitizers on. Then they'll use your own tests as input to fuzzing frameworks, and they'll use the fuzzing frameworks with sanitizers and try to find bugs. I mean, these are things that you can do in your own project, right? These and often they build really complex tooling around your specific product, which if you had it yourself, this could be in your continuous integration pipeline. This could be something that just ran, right?
Yeah, I'm shocked at the number of companies that are, I mean, a small shop can't afford something like Coverity. Coverity is kind of expensive tool, but a large shop that doesn't have Coverity on a continuous build kind of situation, to me is I don't see how you could be talking about, secure code if you're not doing that. I mean, that's just such a no-brainer. It's gonna be an investment in both time and money to set up, but having done that, it's just going to reap rewards going forward. Yeah. How could you not?
But the thing is, we even the free tools are getting really good. Yeah. So just if you're a small shop, just having one part of your continuous integration, just running your own tests, but with address sanitizer on, or having Cpp.chat. Or even I don't want to do advertising for your company, Phil, but a lot of IDEs like Sea Lion have integrated a lot of these tools in the IDE, so you could just get a little red squiggly under things that would normally have to wait until compile time. So just getting as much tooling as you can and pushing it as close to the developer as you can, so they can get that immediate feedback, and I think is super important.
And just to be clear, I don't mind at all if you advertise.
I was going to say, we have a policy on this show that we're okay with advocating for JetBrains, right?
But also, you partially answered a question in the chat, actually. Asking about best practices to find the not well tested and complex code. So you talked about fuzz testing and code coverage, but just to throw in as well, property based testing and approval testing to some extent, although there's a slightly different focus. Are together with fuzz testing. They're the things I was talking about in my workshop for exactly that question. And bringing that back to TDD, TDD doesn't get to those things. TDD gets to the things that you did think of. So you need all those testing practices to get to the things you didn't think of.
Yeah,
you need all of them.
And that's the thing that's usually where our testing is lacking. We're good at, like you said, it's like we make tests for the things that we think of. But what the security researchers are looking for is the things that we didn't think of. And they can do that with things like fuzzing. And fuzzing is, if you haven't looked into it as a technology, as a nerd, I would definitely look at it, because there's so much cool things that are happening. And the way it's developing, they're making grammar-based fuzzing. So they'll specify the grammar for your APIs to be able to actually pass the parsing stage of whatever you're using to parse, and they do coverage-based fuzzing. So they will actually measure how much of your code they are managing to reach with their fuzzing, and then they're using like evolution on that. So they will see, okay, I did a mutation on this input. Did I reach more code? Did I reach code that I don't reach normally? Okay, then I will keep that and I will continue to mutate that. It's like there is so much cool things that are being done within fuzzing frameworks. So definitely something that is interesting, even if you're just curious.
To go after the things that the challenge with programming, and there's no aspect of programming by itself that's hard. The challenge of programming is that you have to deal with all the aspects at the same time. In other words, I look at this code and I have to make certain that I'm, clean for Unicode. I have to make certain that I don't leak. I have to make certain that I'm exception safe. I have to make sure that I'm reentrant. I have to make sure all of these things, any one of which I can look at that and answer the question, yes, I was thinking about that when I wrote this code, and so the code is really going to be reentrant clean. But because I was focusing on that, I didn't think too much about, am I treating these strings in a way that's Unicode clean? Am I dealing with, you have to think about all of them at the same time.
Yeah.
And that's the real challenge. And in fact, when I did code reviews, which I hated doing code reviews, the technique, the way I did it was I would make a list and I would say, these are the things that I want to look at. I want to make sure this, this, and this. And I'd make a separate pass for each one. I wouldn't try to look at the code and say, does this code do everything? I couldn't deal with that. What instead is I would ignore everything and say, I'm just looking at this to see, are we good from a leak point of view? And look at everything and say, does it leak? And then I'd make a pass and say, are we good from, because that's the only way I knew how to do it, right? Otherwise, I'm just looking at it, trying to rewrite it the way the original author did. And if the original author had so many things they were thinking about that they forgot one dimension, I'm going to repeat the same thing. I'm going to forget the same dimension. So, so I think that's actually what the challenge of writing code is that you've got about 12 different things you got to think about when you write code that, oh, you got to be good with this, got to be good with this, got to be good with this. And that no human can think that way. And that's why, as you were saying, you know, the security researchers are trying to go after the things you didn't think about, because the things you did think about, probably you did a relatively good job of that. Nobody's going to be perfect, but if you were focused on that, it's unlikely there's huge mistakes. And then those one or two mistakes you're going to catch, because you're also going to test to make sure you accomplished what you were thinking about, right? That part of the code's good. And they're going to go after, did you even think about this? And I remember on a certain product, I'm not going to mention the name because I thought it was pretty good overall, but I was looking at the passwords on something. Well, I guess we got a bug on this, and it was something weird was happening. And it turned out that the password system was fine, but the UI was getting tripped up. It would show, you know, dots for your passwords. And the way they were doing that was a little game they were playing internally. And so I went back to the tester and I said to her, I said, does your password start with a capital V? And she was really freaked out because the way they were manipulating the characters you were typing in, if your password happened to start with a capital V, then instead of getting the dots, you would get an empty thing. And that was the, you know, and so it just so happened that her password started with a capital V, and she caught the one thing that would, you know, it wasn't going to affect the security at all. You weren't going to get in. It didn't affect anything. It was just the UI did the wrong thing if that was your password as you were typing it in. That's the kind of thing that, you know, nobody was thinking about that. They were thinking about the security. No. They weren't really, you know, those are the kinds of things, right?
Yeah. And the thing is, I guess, I remember when I started in this industry, and then people would talk about making products that were bug-free. Why can't you make things that are bug-free? And trying to explain to people that the cost, even if you could do this, like even if it was theoretically possible, the cost would be totally prohibited. It'd be so high to just find everything. But we are at that same point now. Nobody believes you can make bug-free software anymore. Everybody believes it is within acceptable levels, within what you think is okay. There will always be things you don't know anything about. There will always be things that can come in the future. You just kind of have to continuously work it. But security is the same way. And I have clients that come to me and they say, we want to be 100% safe. And the problem is that you can't be 100% safe, because you probably, where you have an issue is in the things that you didn't think about. So the thing is, there will always be some things that you didn't think about, but you might be lucky and nobody finds it. But one of the things that I talk about in my course, which I think is important, and I think we know really, is making things safe under refactoring. Because even if you make it right, like even if you thought about everything, even if we go through all of the code review and everybody's happy with the code, then, you know, a year down the line, somebody has to add a feature, make a change. And suddenly one of your underlying assumptions that they didn't realize was there was broken. And it happens all the time.
So it might be beneficial to document those underlying assumptions. I'm just saying that.
Yeah,
that might,
but oftentimes it's like, and the thing is, and me and Phil were talking about earlier about documentation, that we have a tendency to think that we document for other people, but oftentimes like that other person is just us in the future, where we just pick up something we wrote last year and we go like, oh wow, what was I thinking? What was this? Okay, how did this work? And the thing is, when we're sitting in front of it and we have everything in our heads, we think, oh, it's obvious, right? This is like how everything is. But a year down the line, when you don't have it all in there anymore, then you're like, how is this again?
There was another talk that I saw today, actually, given by a couple of developers who worked for the courts in Norway. And they had one experience where they had to deal with properties, that ownership of properties, like houses. And there was one situation that actually brought down their whole system, where the property was actually owned by itself. And so, of course, no one had thought this case would ever exist, so they got stuck in this endless loop and crashed their entire system. So, of course, they fixed it, and they put a test in that said something like, weird case where property owns itself that we've seen in production, as the name of the test. As a way to document that situation so nobody would ever overlook it again. I thought it was really nice.
Yeah.
I
still don't really know what it means.
Peter Bindos from TomTom, he had a talk on GPS systems also yesterday, and in his answer to one of the questions, he said in one of the systems you would have the system, it would crash if it took a right turn in a certain intersection. And he said that there was no way that they could know if there was no problem, because what was it? I don't remember his exact choice of words, but I think he said something like, the world is really big.
There are lots of places where you can take right turns.
Yeah, exactly. And it's true, right? It's like there are other right turns in the world.
Left turn should be fine, though.
Yeah.
Who would ever want to take a left turn?
Exactly.
Implement it in terms of right turns anyway.
That's right. All right. Well, it sounds like you guys have had a lot of fun. Well, actually, we were talking about your presentation. Was the keynote a similar subject? You said you did a keynote and then you did something today. Was that the same topic?
No. Well, the talk today was related to my training, but the keynote wasn't really. The keynote was related to more of my I guess we could call it activism that I've been doing in Norway, where it started 2 years ago now, more than 2 years. Where I started writing about the Norwegian election system and wanting to ask for data and reports to try to figure out the security of Norwegian election systems. And over time, it has become like a big thing here in Norway. So I've been on TV and newspapers and stuff, even on the radio, which I thought was fun because there's radio.
Okay.
You know?
So before we get in the actual subject of it, was this your first keynote?
Well, I did a keynote at Cpp.chat as well, but it wasn't in the beginning, so it kind of felt different because it was in the end of the day. Whereas this one was like the first one that people go to, so for me it was different.
Yes, we call it a plenary.
Yeah, it's called a plenary there, and this one is like it was the first thing that everybody got. Yeah. So yeah, I guess it was my first keynote. Yeah.
Well, it doesn't sound like it was. It sounds like your second. It was the first opening keynote. But I'm not sure an opening keynote is necessarily. Perhaps you have more pressure on you. I guess expectations are really high or something like that. I don't know. But I mean, to me, a closing keynote can have just as much expectations. So. After seeing all these other speakers, now they're going to say, okay, now you're going to say something special. And that might say, well, that's putting a lot of pressure.
Yeah. Now you have to beat everything that's been before. Right. And also when everybody is mentally exhausted, now we're going to have
you get to follow all these other speakers, right?
Yes. No, but it was fun. But it's also a little bit of like pressure on me here because I'm talking about elections in Norway,
let's talk about
but also
subject,
at a and also
before we do talk about that, I did a little poll yesterday on the channel just before the show was going to be. I said, who would like to hear about electronic voting? And I'm not sure we got reliable results because people trust. So I think we'll just go with it.
So is the Norwegian system using electronic voting?
No. No, it's not.
Are you advocating for that, or are you just advocating for better auditing of the non-electronic voting?
No. Well, basically, the state of things took a while to actually unearth the facts, because it was very hard to get the state to actually tell us and to give the information. But what was the state 2 years ago was that we vote on paper ballots in Norway, but slowly but surely, behind the scenes, they had been introducing computers to count the ballots. And there was no audit of the count, no audit of the software either, no audit of anything really. And this had been done basically while all Norwegians thought that ballots were counted manually. They actually, a large portion was counted only by computers. And so then the question was, okay, but what kind of, well, there were many questions. So I was asking basically, what kind of computers? What kind of system is this? Do you have any reports on the security? Have you done anything? And basically, it turns out it was basically random Windows machines. You were allowed on a local level to basically reuse computers you had lying around, like normal desktop, laptop, Windows machines. And then some kind of table scanner that you would connect by USB to this thing, and then you downloaded some software from the Directorate for Elections to run there. And there hadn't been really any evaluation of the security of the system, and they were all online, of course. And then it turns out slowly but surely we realized that it's actually quite a lot of the votes. In the end, probably around half of the votes in Norway were only going to be counted by computers, with no audit of any kind. And slowly but surely, more and more of this became apparent, especially the fact that it was on the internet, which wasn't something I'd even, like in my first time I wrote in the paper, I didn't even ask if it was on the internet, because I just assumed it wasn't.
Nobody would be that stupid, right?
Yeah, so it didn't even occur to me. So basically, what I've been doing is basically asking for information, and then telling people the state of things, and asking to get data, and basically just asking questions a lot. And the answers I got, apparently they didn't want to give them to me because they didn't have any answers, but I didn't know that at the time. So so basically they've been getting their act together. So they've been having security audits, and they've done penetration testing. And but the most important thing is that they didn't have any audit of the count. And that's something that I was working very hard, that we need some way to check if the computers are actually producing the right results. And this year, after there was I don't know what the English word for it is, they put out a proposal. The government puts out a proposal, and then anyone can write an answer to it or say what they think about it. And so I wrote my answer, and then basically all of Norway's different municipalities wrote their answer. And it was basically me against 200 other organizations. Because they are all, and I think this is our fault as an industry, because they were all, why can't we trust computers? And that's sort of how we train people. We train people to think that computers are impartial, that they are infallible, that how could a computer make a mistake? And it's just like, no, the computer can make a mistake, yes, but we can also make the computer do other things. A computer is not objective. A computer is colored by whoever makes the software, even the hardware. And we're not very good at teaching the population in general this. And so it became a lot of the issue was just teaching people how do computer. But in the end, I wrote it. I didn't think that anybody would listen to me, but this year and this winter, they passed new regulations in Norway, which was against everybody's will but mine, basically. And it says that all ballots in Norway have to be counted manually at least once. So now we have one preliminary manual count, and maybe machine counted result as well. But then at least we have two numbers. We can compare them to each other. We can do some kind of evaluation. Currently, there is no procedure for handling if these two numbers don't match. But that's my next goal. We need to have some way of handling irregularities if they happen, and propagating information and handling it in real time, because an election is a real-time event. You have data flowing from all over the country, and things are being added up, and numbers are being presented on TV, and candidates are accepting results and not accepting results based on live information. And so we also need to propagate any kind of event. It has to also be propagated live, or we're going to have a problem. It's a work in progress.
That sounds like fun. And it also sounds like it's related to your security work as well, right? You have a bit of a skepticism about systems when you get into security work, because that's, if you don't have that mindset, you're going to be vulnerable to. I mean, this is one of the things that I have sometimes when I ask people. I more or less assume they're going to do something the way I would think it needed to be done. So I don't say, well, how do you verify this? Because I just assume, well, if I were doing it, I'd verify like this, and I assume you're doing the same thing, only to find out later, oh no, we don't do that. We just write this down, and then we come along later and do it. It's like, but you don't verify that that's going to work? No, we just write it down.
No, I had several, but I do the same, and that was also some of the funny parts of this. Like I ask questions and I get the data and I go like, what? You do what? Because I wasn't even expecting, like for example, in Norway we have 3 companies that are allowed to install these. You can do it yourself in like locally in your precinct. You can install computers to do this, but you can also hire firms to do this. And there are 3 that are licensed by the directorate to come and install these counting things for you. But it turns out that 2 out of 3 of these companies are not Norwegian. They're foreign companies. So we have foreign companies that come into Norway and install and do everything, set all of the software, everything up. They even repackage the software that they got from the directorate. So you can't even check the signature anymore. And then they install this. And I was like, oh my God, what? So basically you're just, are any of these people security clearance? It's like, no, they're not. They don't have security clearance. They're mostly not Norwegian. And I'm like, what? Okay, so you're having foreign nationals coming in and installing all of the software and hardware that's going to count like half of the votes in Norway. And they're like, yeah. And I was like, okay. And then I'm reading through some of these contracts. And this is like, it takes a lot of time because I have to read like all sorts of things that they end up giving me. And so I'm reading through the contracts, and then I'm reading, and then you have like the premium tier from one of these companies. And the premium tier includes remote support. And I'm like, and then I'm reading like, what? No, they have remote access to the computers that are counting the votes.
To make sure it's working right. Well,
this is like
it sounds to me like you're not being skeptical enough. You seem to think that because someone's Norwegian that they wouldn't want to tamper with the votes. I don't know. I think that you should. Your skepticism shouldn't be about foreigners. It should be about human beings, because human beings have their own agenda, and that's the issue.
But that's the thing. The thing is, nobody was suspicious of anything, and I was just asking like questions because I wanted to know how it worked, and I wanted to see that they got all their ducks in a row. I expected that they had all their ducks in a row, so I was continuously shocked on exactly how lax it was, exactly how much they hadn't really considered the security of the counting system at all. And that was really shocking to me. And it just shocked me again and again, realizing that there had literally not been a single person who had considered this problem at all. And so I might have been naive, but at least I kept on asking questions. So.
Fortunately, election meddling is not something that happens.
But the good thing is now we've gotten some good legislation in place. I'm hopeful for the future. Of course, we also at the same time now have a commission that is doing research for a future election law, and they've had several meetings talking about internet voting. So I see a fight in my future.
Yeah, I was saying before the show, I was saying I don't understand how you could possibly have an auditable online or electronic voting system that doesn't in fact simply reveal what everyone voted for. I mean, that's the only way you could do it, is that I can look up and I could say, it says John Cal voted this way, and I could look at that and I could say, okay, I don't know how everybody else voted, but it's accurately reflecting me. But of course, that's not the way we want our voting system to work. You want to have that kind of voting privacy. And given that, how can you possibly audit and say, well, obviously it counted the votes as they came in? You'd have no way of knowing that. You could write a very subtle thing that says, I accurately reflect all the votes that happened, but I'm biased this way so that every third vote for that candidate I actually put on the other candidate. And there is no way to look at the results of that. I mean, you just can't have a third party look at this and say it has to.
They're trying, like all the blockchain boys all over the world. They're trying. That's basically, you have a lot of people like from type Bitcoin blockchain backgrounds who are coming in here, and they're trying to do all sorts of cryptographical tricks and reshuffling and all sorts of things. But the thing is, in the end, no matter how much you make something that, and until now we haven't really seen anything that is sound, but even let's say that you have a system. Imagine I make a system, you audit it, you are completely convinced it is completely correct. On election day, how do you know what is running?
Yeah.
How do you know that what I showed you is actually what is running?
Yeah. Actually, a blockchain could be used in such a way if you could anonymously distribute IDs so that the individual could say, I'm going to look up my ID. No one else knows who that person is, but I know this one.
Yeah, but you're breaking another part of election security, because now you can prove what you voted. And if you can prove what you voted, now people can coerce you to vote against your conscience, because they can check that you did what you were supposed to. But also people can pay you. So now you can sell your vote because you have the possibility of proving that you voted the way that they paid you to vote.
Yeah.
So this goes against another part of election security, which is basically vote selling and coercion and persecution. So the thing is that everyone wants to put lots of computers in this, but when it comes to like manual election, manual ballot counting, paper ballots is a really simple system that is secure in the way that it relies on lots of people. So to be able to manipulate an election that is based on paper ballots and people, you need a conspiracy, because you need so many people to be a part of it to be able to flip an election. They need to be distributed on many physical locations, and they need to be physically present. And that's very risky. Instead of, if you have a computerized system, if you are able to, you can even do it remotely. And you often have a single point or very few points of failure. And it might be enough to get just 1 point to flip an entire election, because you have control over so many votes at the same time. And so I've described tons of attacks to the government here on how I could manipulate an election as a private citizen, as one person. And some of them are super simple. Like in Norway, we had paper ballots. And so you pick, and in Norway, it's quite simple system. So the paper ballot is basically one per party, because we vote for a party. And so the party name will be on top of the ballot, and then you select the party that you want. And that now you have the paper ballot, and you put it in a box, and that's your vote. But the thing is, the computers that were counting the votes, they weren't reading the text on the ballot. They were reading a number in the corner. So I tell them, okay, fine. I can make this is just paper, right? I can print paper, and all I can do is I'll print a party that I don't like. I will print like a few thousand, which has the number of the party I want, but the name of the party that they'll vote for. and then I'll just distribute it on all of the in lots of polling locations, and I'll go home. Just,
right. Yeah.
Because the thing is, nobody's actually auditing the way it was. Nobody was actually auditing the results.
Yeah.
So nobody was actually looking at the ballots, and everybody was like, yeah, but we have paper ballots, we can check. Yeah, you can check, but nobody actually checks. So it doesn't really matter if you can check as long as nobody's actually checking. And so I said I could easily flip an election in Norway just by paper. It's like the most low-tech hack in the world. And now I said it on the internet. So now everybody fix your election system.
Yes, I'm certain that people wanting to affect ballot outcomes are all listening to the CPP chat. But getting this back to C++, are there any features that people are talking about either for 20 or for 23 that you find particularly interesting from a security point of view, either making security easier or making security harder?
Well, I have two things that I have been thinking about, and I've been talking about a little bit on the internet. And one of them, some people say that there might be a proposal already, and that is memset_s, which is in Appendix K for C11. It's one of, but I'd really like to get it into to 20. Just that one function, not the whole Annex K. There's lots of stuff in there. But memset_s, because currently today, this is an unsolved problem. Because what the problem with memset in the security context is that you will often have some kind of secret in memory, maybe a password, maybe a key, something like that. And you want to keep it in memory only for the portion of time where you're using it. And the moment you're not using it anymore, you would like to remove it from memory, just in case, something later can dump the memory or something later can retrieve it somehow. So you want to keep that time period as short as possible. And what they do is then that when they're done using this memory for this secret, then they try to erase it from memory by writing zeros over it or whatever.
And of course, because nothing then reads it, the compiler looks
exactly.
at that and says, you're doing a write that you never read from, so the write can be optimized away.
Yes.
And security people tend to not like this.
And also the problem is that it used to, right? The compiler used to leave it in. and even worse, if you compile and debug, the memset is still there. So as a developer, you're compiling in debug, you check, even if you go on Godbolt, it's right there. The memset is right there. If you go and you check your memory, like actually go in and physically look at the memory in debug, it's zeroed out. It's only in an optimized build and only with newer compilers. And the problem then becomes that this was a hidden bug, like in lots of places that ended up having security issues because of a recompile with a newer compiler. And we don't have a cross-platform solution for this. There's many attempts on many different platforms, but today there is no cross-platform solution. And so I'd really like it if we.
Is there a solution coming from the new approach to volatile? So the classic approach to volatile has been that we say that an object is volatile, meaning we can't optimize reads and writes. And that's an interesting and simple model, but it's not how processors actually work, because a processor doesn't really think of, oh, this memory location is volatile and I won't optimize reads or writes. Instead, every individual read or write is treated separately. So it's up to the compiler to say, this is a read or write to this thing, and I therefore can't optimize it away because the thing is volatile. But I think the new approach with what they're trying to introduce, and I haven't read the proposal, but I think the new approach is to try to say, we're not going to say that objects are volatile. Instead, we're going to say this particular operation is volatile. I want you to do it no matter what, even if you think it could be optimized away. That approach would allow you to say, I want to make a bunch of volatile writes to this memory, and I'm going to write 0 to all this memory, and it's a volatile write, which says even if the compiler can prove it's never used, it still has to do it. That approach, I think, would be a valid cross-platform approach.
Yes, definitely. I'd be super happy if we solved that problem. Okay, then I have my second issue.
Okay, all right.
No, because I did it in my presentation today. Because if you gets is in a CW common vulnerability weakness enumeration. It has its own number. It's called inherently dangerous function. And get is deprecated. You get lots of warnings. It's basically considered this is basically a Stack Overflow waiting to happen.
I'm sorry. What do you guess?
Get like get with an S afterwards.
Gets. Okay,
like
I'm sorry.
But gets.
Right. It is a Stack Overflow waiting to happen. There's no safe way to implement gets. You can't put gets in professional code.
No, but the thing is, what I showed in my presentation today is that you can use cin into a stack allocated array with the exact same effect, and you don't even get a warning. And that is something I want. I want there to be a warning. If you use cin to read into a stack allocated array, I want there to be a warning, or a truncated. I don't care, but at least a warning, some kind of diagnostic that will say, okay, this wasn't as good of an idea as you thought it was.
Well, the standard doesn't actually doesn't deal in warnings, right? I mean, it simply says something's either legal or it's not, and if it's illegal, the standard can say that a diagnosis is required or that a diagnostic is not required, but it actually doesn't deal with
having cin reading into stack allocated array is a Stack Overflow waiting to happen. It is just, how can even the user know you shouldn't type more than X characters? Are you going to give them a little like text string? Like, don't write more than 8 characters because then I will have undefined behavior. That it doesn't make sense.
Well, they won't know what undefined behavior is. So what you'll have to say is don't type in more than 8 characters or your cat will get pregnant. That's guaranteed to be people saying, I got to see how this works, right?
And I don't even have a cat.
We need your warning. The one you read in the beginning is like, yeah, your neighbors can attack you. And
that's right. Your neighbors can attack you and ask, please ask workmen for ID. That's
yeah, there you go.
All right. So I'm not sure exactly. No, I think get S is probably, and I think people have recognized that for a while.
Yes.
And I'm not sure on the CN. CN is also kind of a little bit scary just in general. I'm not sure. We have had people talking about what's the author of the format library.
Victor Zerevich, who had on
Victor,
just
yeah,
last time.
I was trying to think of Victor. So he was on, and yeah, I think input is just way harder than output. Output's not easy. Getting output right, that's hard. But
yes.
But that's child's play compared to input. Input's got its own set of.
And the thing is, right now, like this semester, I'm substituting for a professor teaching C at a college in Oslo, and it's made me think a lot about how we teach. Like now I'm teaching C, but it also makes me think about how we teach C++, because one of the first things that we do whenever we teach anybody programming is, okay, so here you have 2 numbers, then you add them together. That's like one of the first things they do. And then they have to write that out, okay? And then they always make a program where they read in a number. And then they have strings that they have to read in. And it's like, we basically, in C++, if we start the same way, we're putting them in one of our most dangerous corners from day one.
Well, no, not if you're reading into a string. And I think this is one of the issues that Bjarne has said is, everybody knows the first program you write is hello world, but the second program is essentially what is your name, hello you, right? And he points out that if you do this with std string, this can be safe. When you say it in C, there's no way to do this in a safe way.
No. But even adding two numbers together, like in C++, you're very quickly in undefined behavior land, and that or multiplying two numbers. And this is something that if you're coming from any kind of other programming language, they haven't even imagined this was an issue.
Right.
It doesn't even occur to them that this is an issue.
Right.
And so that is like, as a teaching perspective, that is, it means we have to start talking about undefined behavior from the beginning.
Mm-hmm. Well.
And maybe we should.
No, I think we should. I think we should, because it's a very important.
Yeah.
I think people talk about undefined behavior as some evil thing, and I think we should explain, no, undefined behavior is what makes our programs run fast.
Yeah.
It's by saying, you stay away from these things. If you write this, we can make this fast. If you want to write this, we can't deliver it fast, and so we don't even try. And so we don't say what will happen if you do that. So don't do that. And you're right. We should do that very early on. Maybe not the first day, but very early on.
But it was funny. I asked when I got this job, because it was an emergency thing, because the previous professor had an emergency, and so I asked on Twitter, like, what are the things that you thought was the hardest when learning C? And I would say probably 90% of everyone who answered said pointers, anything to do with pointers, basically. And then you had 10% who said that they thought pointers were fine. And all of those people, they came to C from assembly. And so for them, okay, pointers, oh yeah, that's how you do addresses. That's the syntax for that. And for them, they had the mental model. But what I'm seeing now is like people coming from higher level programming languages to C, they're coming from languages that have a C-like syntax, but are totally different in semantics. And so when they land in C, they think they know what they're doing because it looks familiar, right?
Yeah, I've often felt like I've seen people who introduce some new language that they think solves a lot of problems, but in order to make it familiar, they use the C syntax. And I think the C syntax is one of the biggest problems with C. It's nice and concise, but it isn't a well-designed syntax. And I think that's
spread so far now.
I think that using the equal sign to mean assignment is convenient, but it breaks what equals means. And I think laughing at literally centuries of mathematical notation is not a good idea, and just ignoring that and saying, oh, we're not going to do that anymore. So I'm sympathetic with that. Actually, I think it was Joel Onsplosky who essentially says there are two concepts in at least in beginning computer science that are the hard things. You can teach any group of young students basically how to write code, even how to write loops. It's all, they can understand it. It's all. But when you start talking about pointers and when you start talking about recursion, those are the two operations that separate people who really can become programmers from people who are going to have to work for a living, right?
And off by one errors.
Yeah. Yes, that's what I said. Those two things.
Oh.
Thank you for setting me up for that one. What?
But yeah, no, it was a good one. No, both of those things, like I've been trying to teach for a while, both professionally and privately, and both of those things often benefit from having a mental model which matches more how a computer actually is.
Right.
And very often when we teach higher level programming, we don't teach them how it works. And so especially like things like recursion, understanding that the state of this function call is kept someplace while you are calling itself again, and now you have a new set of local state. And the moment you teach people about like a stack and how and stack frames, then this suddenly clicks, and people were like, oh, okay. And then I returned, then I actually popped that off, and then now I'm in this context, and then suddenly it makes sense. But often we try to teach without teaching the underlying computer.
I remember that I actually didn't learn C until after I had done some assembly language programming. And when I realized, oh, there's a special increment operator, it made perfect sense because the computer has special increment hardware. But I think had I come from that otherwise, I said, why is there something special to add 1 to something? Why isn't there something special to add 2 to something? Why is 1 special, right? Well, you know, if you understand what the computer at the lower level is doing, we realize there's almost always special hardware to do those kinds of increments. So why not have a special? It makes perfect sense. And I think, you know, one of the things that Alex Stepanov said in a panel, I think this was a panel of people from a number of different languages, and I don't know if he was trying to be provocative or what, but he said essentially, he said the only 2 languages you should that are really worthy of any kind of study are C and C++. And the reason is that these are the languages that try to model what the machine is instead of create an artificial world of what the machine should be. And I think there's a lot to be said for that. I've talked to people who said I remember a specific situation where someone was having a particular kind of bug was happening, and in talking to the engineers about what was going on, none of them actually understood how the machine worked. They simply understand how the language presented machine, and so if it failed in some interesting way, they had no clue why that might actually fail. And of course, because he had done more than, I don't want to say it was Java, I don't even know what language they were talking about, but he had an outside world of what was actually happening with the hardware. And he was essentially trying to get them to see this is the cause of the bug. And they just couldn't see it at all because they didn't understand how the machine actually works. They only understood how the virtual machine worked. And the virtual machine, you know, didn't have this failure. It was failing at kind of a lower level. The virtual machine wasn't actually, I don't want to say it's a bug in the virtual machine, but the situation was happening because the virtual machine was doing something that you wouldn't expect of it, but you would expect if you understood what the hardware underneath was doing.
Yeah. And so we have mental models, right? We try to when we're imagining the execution of our program, we do have mental models. And if those mental models are too simplistic or lacking in detail, then we end up processing it wrong in our heads and it doesn't match the real world. And any kind of abstraction will be leaky, and there will be things that are bubbling through that might not match this perfect world. But I think that happened to us as well. Speaking of modeling the machine, with the Spectre and Meltdown, because suddenly our low-level assembly was not so low-level anymore. We had, and that was very interesting because suddenly I sat there feeling like assembly is really a high-level programming language.
Well, with today's modern programmers, it is.
All models are wrong, some are useful.
I'm blaming this entirely on you, Patricia. You've got me all excited. I want to start talking about this a lot more, but we've run out of time. And unfortunately, I have a hard thing because I got conference stuff that I've got to do, and I've got deadlines that I've got to meet. So I've got to call somebody, and so I guess we'll have to have you back, Patricia, and you can get me all wound up again. But traditionally, we end the show by encourage. Actually, I should say this. Do you have any last words? I don't want to cut it off. I got to get out of here. But Phil, do you have anything you want to say, or Patricia? Any parting thoughts?
I do training, so hire me. I do consulting, so I should be better at the marketing part of this business. So
it sounds to me like you got that priority in there. How about you, Phil? Can they hire you to do consulting and training too?
They absolutely can. I also do conferences, and I just really briefly wanted to mention that we've just announced the keynote speakers for C++ on C. Hannah Disikova and Walter Brown, and tickets are on sale. So I'll put a link in the show notes for that. But we'll talk about it a bit more next time, maybe.
I'm looking forward to seeing them both in just a week and a half. I'm really excited to see them. So that sounds great. And it's not February next year; it's June.
June, that's right. Yeah,
June.
Yeah,
but it's not too early to get tickets. Is that what you're saying?
Tickets are on sale now. In fact, super early bird tickets, which won't last long. Ooh. So get them while they're hot.
Get them while they're hot. Okay. We traditionally end the show by wishing everyone safe coding, and in particular, I think that's appropriate. So can you join us for this, Patricia, and say, please, everyone, safe coding.
Secure coding.
Everyone. Secure coding.